So the next half hour, I will now dive into the cybersecurity aspects for machinery. And also here, once again, unfortunately, I cannot avoid the topic you have seen already a lot of standards, regulations, and acts for the various things. Well, guess what? There are more to come because, of course, everything around cybersecurity has yet another regulation, directive, or standard. And so it gets worse with the more we work on this. So before getting into depths of cybersecurity, I just want to make sure that we are a little bit on the page here of what we are trying to do on the CAN and CAN open level or even J1939. And there are things in cybersecurity that I would say for us are a little bit out of scope, because when it comes to cybersecurity, then typically you talk about the three pillars here. That's something that IEC 62443 introduced. So you have your people, you need to trust them and you need to trust their competence. So this is about not plugging a USB stick that you found in the parking lot somewhere into your mobile machinery, right? So you need to educate your personnel not to do that, these sort of things, and get them away from phishing attacks and that sort of stuff. Then you have your processes. These are your processes, how you ensure that you develop a secure product, because when it comes to security, there's typically the terms either defense in depth or design by security. So if you want to design something by security, then of course you have to start early already in the specification process and in the development, and in all stages you have to think about how to get security in there. So again, this is something for now I would keep out of the focus. My focus here is now on the technology. So if we look at anything CAN communication, what measures can we add to existing classical or CAN-FD communication to make it more secure? So this is the focus of the next half an hour here. We also need to briefly introduce security levels, because when you try to protect your system from threats, from attacks, then of course you have to know a little bit who is your attacker and whom do you want to attack from. And so similar to the safety levels, there are also security level defined. And here in 62443, these are the security level 1, meaning this is protecting for casual or coincidental violations. So this is more like, oh, I dropped my coffee mug on the keyboard and accidentally the password showed up, something like that. So it's not really much of protection, and it's not really considered good security level. So it really starts with level 2, because now we are adding intentional violation, meaning somebody on purpose, using simple means, generic skills, tries to mess with your system. So to visualize this could be even a student, a script kiddie, somebody who just has too much time and is bored and try to mess with your machinery. So this is level 2. When we come to level 3, then it's using sophisticated means and specific skills. So these guys are doing it for a purpose. Somebody pays them, or they want later to extort money from you or steal something. So this is taking it to the next level. And the highest level is basically the same, but with extensive resources. And I think what they typically have in mind here is what they also refer to as state actors. So if there is a rogue state or a war situation where somebody tries to bring down your infrastructure intentionally, this is where you reach safety level 4, security level 4. So Tilo talked too much about safety now, so security. For us here in the CAN world, the challenging part is that there is some knowledge transfer between these. What do I mean by this? Well, if you go out there on Alibaba or some other international web pages, you can buy CAN security devices that help you to open your car even if you don't have any keys. And well, nobody at security level 2 would be able to build such a machinery. But because you can buy them online and easily get them, suddenly it allows someone at security level 2 to execute attacks that are at security level 4. And so this is really something we all have to monitor. There's no specific rule or regulation how to work with this, but the more of these hacking devices preloaded with software come out, we just need to stay on top of these and evaluate them continuously and see what we can do. Now, as Tilo had showed, CAN comes from the last not only century but millennium. I think that was the word you were missing. So at the time CAN was designed, cybersecurity was not really an issue. So of course, there are a lot of things that an attacker can do. If you have access to the wires, you can attach some sort of sniffer or interface to read everything. So here goes your complete confidentiality and privacy. Someone who has access to the wires on a classical CAN system sees everything, but they can also inject everything. So a command from one node to the other could simply be repeated and shoved in here from such a device. Of course, these days, more and more machinery has some sort of remote access. So through internet or maybe Bluetooth to a phone or tablet, there is some remote access. And of course, that is a potential attack vector, an attack surface. And as I mentioned earlier, any external memory. And the most sophisticated attacks would try to go after installing their own modified firmware into some of these nodes. So there's quite a few options. And there are a few things that we should keep in mind and that we all need to convey to the auditing authorities who is auditing our security, is that there are a few things that we can simply not protect from. So if someone has unlimited physical access to this entire system, so suddenly maybe the attacker potentially becomes the user of a machine because maybe the machine has some safe load limit, and part as of the safety, it is ensured that a load limit is not exceeded. Well, somebody might try to hack this mechanism so that they can load more on top of their truck and do more hauls per trip and things like that. So suddenly you have a person, potentially your driver, user, owner, that has unlimited physical access to examine everything here and be able to mess with the system. Well, in that position, you have access not only to CAN, you have direct access to all of the nodes, and there's a lot of side channel attacks and other things you can do. So this is something we can't protect with so much here with security on that side. And also quite a few regulations and acts always say, oh, you have to do something against denial of service attacks. Well, your ultimate denial of service attack is, of course, cutting the wires. And if somebody has physical access, just even briefly to the wires, of course, you can cut them. So that's really something you have to keep in mind, that we cannot protect from everything. And I'm not sure if I'm spending too much time with this slide, but it really is also important to understand. If look at this remote access here. Now imagine we do something here on the network with cryptographic methods to really protect it. Well, this remote access here has a purpose. So if this is a diagnostic interface, it must have the authority and the keys and everything to have access to this networks. So if this is compromised from the internet, then again, it doesn't matter what kind of cryptographic methods we have installed here. If somebody is inside our diagnostic machinery, hey, then they are inside the system. So there's a lot of limits that we cannot really pursue and protect from. So the main difference we still need to divide and look at differently is the remote attacks from an internet site versus the physical attacks. And so internet-based attacks can, of course, only happen if either a gateway was plugged in additionally to on the network, or it's one of the existing legitimate access points. Well, these must all be well protected with all top-notch, top-of-the-line security methods that are available in the internet. Otherwise, there's nothing else we can do, as I just mentioned. Now, when it comes to the physical access, then the nice thing is here that for us from the protection side, where here on the left side, an attacker has access potentially to hundreds or thousands of systems, physical access is always just one at a time, assuming there's not an army of attackers out there. So the protection here really doesn't need to cover multiple devices. It's really machines is for one. It's so limited to one system. You definitely want to do something about the exposure of the wires, because it's so easy to connect something to CAN wires. So as much as you can in your machineries, that should be physically stowed away somewhere, not put the wires straight onto the outside beam somewhere. So that connecting a CAN invader device or sniffing device is made as difficult as possible. In some systems, we would say replacing a CAN device with an imposter device might be out of the scope. We have to look at the various cybersecurity requirements. So what specifically, for instance, the Cyber Resilience Act requires us. Maybe here we can also negotiate these issues away, but that's going into a lot of details. Now I'm bringing up a similar picture as Holger started with, and this is truly coincidence, because when I looked at the standards, I also immediately had the association here, hey, that's a jungle of security requirements out there. So we have things like the Cyber Resilience Act, the Cyber Security Act, there's a NIS2 directive and so on. And there's a lot of standards also down here, like 27,000 area for information security management systems. And there's the IEC 62443, securing industrial automation and control systems. I think this would apply to easily to quite a lot of the mobile machinery. Interestingly, so far, when we talk specifically about the Cyber Resilience Act, there is no single standard that covers the requirements that the Resilience Act asks for. So I'm not sure if there is something in the works. It was the intention from the guys writing the Cyber Resilience Act that there should be a harmonized standard for fulfilling it, but I don't think it will be completely completed and available before it's becomes fully active. So we really have to start looking at things earlier and maybe pick and collect various functions from various standards to fulfill the CiA requirements. I don't want to go into the length details here because the CiA requirements are some 20-ish. If you look at the requirements from 62443, this is more a list of 70 or something like that. So I'm focusing a little bit here on the most important things. So again, we also have a risk assessment, and in comparison to the risk assessment that Thilo introduced, where it's about system failure, here it's about, well, intentional failure, so to speak. So somebody tries intentionally to bring it down. So this has to be taken into account with the risk assessment. And then the principles are always that you have to apply security design and defense in depth. In short, it means you cannot rely on a single protection measure. So really only locking your CAN bus away in a vault is by itself not good enough. It needs to be something, some layers of defense. So you have to somehow show in your risk assessment that you implemented multiple layers of defense. And it also needs to apply to the entire life cycle. So that comes to the security updates, software updates, and the CRA specifically requires that you offer these free of charge for the entire lifetime of your product. So They state a minimum of 5 years, but if in machinery you have products that run for 20 years, you would need to provide the free of charge security updates, as far as I know, for the entire 20 years. Then I'm just putting it here for completeness. I said this is not the technical stuff that we worry about here, but you have to report and fix incidents. So if there are security incidents in your machines, you have to provide software updates and a way how this software update finds into the machinery. If your machinery has various configuration methods and also the security can be configured, then it needs to be secure by default. So you may not be able to disable the security functionality. And there's a little bit of a backdoor here for a lot of the other requirements, because specifically in the Cyber Resilience Act, depending on risk. So it depends on your risk assessment if and which of the following measures you have to implement. So things like protect from unauthorized access, or the data integrity and privacy, or you practice network zoning, or you do a security event and audit log. These could all be measures that you apply, but you are not really forced to pick any specific one. It's part of your risk assessment to decide then which one of these you implement. Now I'm mapping this a little bit to can open devices. So if you are a manufacturer of a single device, then you need to definitely do in the future a product risk assessment. And in it, you can conclude, well, this product is only suitable for lower security levels. And we pass on to the integrator, to the system integrator, the overall responsibility to ensure that overall it's secure. Because if we just sell a product, we don't know how the physical access will be in the future. Then the Cyber Resilience Act specifically asks for the software bill of materials. So you need to provide document a list of all the software components and libraries in your system. As I said, you need to provide the security updates. And then some of the other measures, again here, these are depending on the risk, but we need to be able to authenticate related files, because you want to make sure that if you hand your customer any sort of documentation, white paper, support, a configuration of the device, that this is authentic and that it's not manipulated by someone trying to do a phishing attack or something like that with machinery. And also at some point we need to be able to authenticate devices towards others so that we can prohibit imposter devices. And on the more advanced requirements for a product would be that you implement something where you can continuously authenticate yourself. So something like a secure heartbeat. You need to be able to authenticate your configurations, possibly monitor injection detection. And at the end, on the highest end, the requirements can go into cryptographic protection, where we talk about reviewing if and what should be encrypted or authenticated as part of the communication. Once you start with cryptographic protection, immediately the question comes up of key management or possibly even a public key infrastructure. So this opens quite a can of worms. As soon as you start using cryptographic methods, there's quite a few things that come on top of it. Now, on the next level, let me look not only at a single node, but now at the entire machinery. So I call it here a can open system. But on a system level, if you build the machine, oh, sorry, my screen is too fast here. So again, you have to do a system risk assessment for the entire machine. You can include in that the risk assessments of your suppliers and saying, oh, what is the risk assessment already done for the individual components? And then you can also publish and say, well, yeah, it's suitable only for lower security levels, because so far the Cyber Resilience Act, for instance, does not require you to fulfill any specific security level. So you can say, no, it's only for lower level, but you have to clearly document the residual risk. So what are the remaining risks that then maybe you pass on to the owner, and you say, well, this is a forklift, and access to the CAN network has some physical protection. But if you leave it on a construction site somewhere outside with no specific guarding, hey, then you're risking that somebody messes with the system. So you could specify in your documentation how physical access should be limited beyond accessing the cabin of the machinery. Again, you can practice network zoning, minimize the number of gateways, add some security monitor logging so that we log potential attempts. And this is quite similar to before. Again, we can add authentication and cryptographic measures also on a system level, again, with the downside of key management and public infrastructure. So just to summarize a few things and show what I mean by defense in depth and protecting measures, that we really have layer-specific security that we currently talk about. So we already said, well, on the physical layer, we can do something like physical access protection. So putting the entire network behind panels and not making it easily accessible. Then there are quite a few non-cryptographic methods we can do. We can, a system monitor can maybe detect injections. If we know a message comes every 100 milliseconds, and we see, hey, it comes now more often or is out of timing, hey, then maybe somebody is injecting them. So there's non-cryptographic methods to recognize things like that. And of course, there are also cryptographic methods. When it comes to higher layer protocols like CAN Open and Jane 1939, again, there can be non-cryptographic methods. So for instance, we could detect if someone is trying to reconfigure the system. If somebody is reconfiguring PDO parameters while we are operational, then a task doing event monitoring could detect this. And only at the high end would we introduce cryptographic measures. And of course, on the application layer, there's more the acclimation-specific stuff, also including limiting maybe the user access and tracking user logins. So really, there's quite a few non-cryptographic measures we can take and that we can take into our risk assessment. And I could imagine that there are quite a few applications that if you justify this correctly, that with quite a few of these non-cryptographic methods, you might reach certain security levels desired. Let me phrase it this way. But of course, in the higher end, we can add cryptographic methods too. And while those are challenging on classical CAN, they are a little bit easier on CAN-FD or XL simply because of the larger payload and we have more access. To slowly coming to an end here, I just want to show you a few things that we are working on. So we are working on a security event monitor. So some of the, like the Cyber Resilience Act, but also 62443, have one of the measures that you can apply is that you do a security event monitoring. And as I said, if we have an entity or a task somewhere in the system monitoring all communication, there's quite a few things we could detect. So if the entire system here is time-based, of course, we would immediately could detect when things are out of time. We could measure bus loads and see if we are exceeding a limit. If somebody is injecting messages wildly that do not make any sense. So there's quite a few things that can be done on this level, and that's purely non-cryptographic and helps quite a bit. Now, we are currently working on SPSEC, so small packet security, together with Hochschule Offenburg, and that is using CAN-FD. And one of the first products there will be a security gateway where you can extend a classical CAN connection via a secure CAN-FD connection. So here at this end, we talk classical CAN. Here we talk classical CAN. And so if you have, for instance, in your machinery, now look at this here in the background, let's imagine that it's not possible to keep the wires entirely protected within the entire beam here. you could say, you know what, only for this section, we introduce secure CAN-FD communication, and we tunnel all the classical CAN communication through such a CAN-FD secure bridge. And we're currently working on the first prototypes, and they can do this with both classical CAN open and J1939 on this end. And in here, it will be a secure CAN-FD communication. And just to review, so the SP-Spec small packet network security we are working on together with the Hochschule Offenburg. We have this available as prototype right now, and our goal is that from the code side here and the encryption levels that we can do, that we reach at least security level 3, but potentially even 4. But hey, it's still a long way to, in the end, to get this somewhere audited and placed. I think because I'm running out of time, I'll just leave these slides in here for your reference, and later it summarizes what is now the work ahead and what we will discuss in the next cybersecurity higher layer protocol special interest group in about 2 weeks. We have that meeting. If you're interested to join there again, contact the guys at CiA. But there, one of the next things we have to define is what security features can we add on the CAN open layer or levels. So how can we authenticate the 1018 identification? How can we protect configurations? And one of the things really needing protection is, of course, the network management message, which allows you to send resets to every device at any time. And being able to just inject this and having suddenly your devices reset in the middle of working, that's something I think we really need some protection from.